All right, buckle up, everyone, because today we're diving deep into something truly mind-blowing. You've been asking for it, and today we're tackling the cutting edge of large language models, specifically how to make these powerful AI systems even better aligned with human values.
Yeah, it's exciting stuff, really pushing the boundaries here.
Absolutely. We've got a fascinating paper to dig into, detailing a brand new framework called HybridFlow.
HybridFlow, yes.
And this framework is designed to make RLHF, that's reinforcement learning from human feedback, way faster than we've ever seen before.
It's not just an incremental improvement either. We're talking about potential speed boosts that could revolutionize the way we train and use these LLMs. Think about it. These models are already being used everywhere from chatbots to writing tools to, pretty much anything you can imagine.
Yeah, they're popping up everywhere these days.
Now, imagine those applications running not just faster, but also with a deeper understanding of what we humans actually want and need. That's the potential here.
Okay, but before we get too far ahead of ourselves, let's rewind for a second. For those of us who haven't spent every waking moment studying AI, can you remind us what RLHF is all about and why it even matters in the first place?
Sure. Imagine you're teaching a dog a new trick. You're not just going to show it to them once and expect them to get it perfectly right. You'd give them treats, praise them when they get it right, and maybe get a little correction when they mess up.
Right, positive reinforcement.
Exactly. And that's essentially what RLHF does for large language models. It goes beyond that initial training phase and fine-tunes the model based on feedback from us humans. This feedback teaches the LLM to produce outputs that aren't just grammatically correct, but also align with our expectations and values.
So it's like teaching the model to be less of a robotic language machine and more of a, helpful and insightful partner.
Exactly. We're trying to get it to understand the intent and context behind human communication, not just mimic our words.
Okay, that makes sense.
Now, here's where it gets really interesting. A typical RLHF system has several key components. First, you've got the actor, which is the LLM itself, the one generating the text. Then you've got the critic, which evaluates how well the actor's performing. And finally, there's the reward model, which essentially tells the actor which outputs are considered good based on human feedback.
So it's like a little team, right? The actor's the star, the critic's the judge, and the reward model's the coach, guiding the actor toward better performance.
That's a great analogy, but there's a catch. LLMs are huge. We're talking billions of parameters, massive data sets. It's like trying to cram a supercomputer into your pocket.
Yeah, and that has to cause some issues, right? Like I've definitely noticed some AI tools can feel a bit sluggish sometimes.
You're exactly right. The sheer scale of LLMs creates a massive challenge for traditional RLHF methods. They just weren't designed to handle that level of complexity. It's like trying to run a marathon in flip-flops.
Yeah, not the best footwear choice for that situation.
Now, traditional RL frameworks often use what's called a single controller paradigm. Imagine a single conductor trying to lead a gigantic orchestra where every instrument is a tiny part of the model.
I can see how that would get out of hand pretty quickly.
It works okay on a smaller scale, but with something as complex as an LLM, it becomes incredibly inefficient. So we need a new conducting style, something a bit more agile.
So what? We need to break up the orchestra into smaller ensembles.
That's a great way to put it. And that's exactly where HybridFlow steps in. It's not just about speeding things up. It's about fundamentally rethinking how we manage these massive systems.
Okay, I'm officially intrigued. Tell me more.
Well, let's think about a busy restaurant kitchen, right? You've got all these different stations, the grill, the prep area, the dessert station. Now, imagine one chef trying to handle everything all at once.
Oh, that would be a disaster. Burnt dishes, missed orders, and one very stressed out chef.
Total chaos. Now, imagine a team of chefs, each specializing in a specific task, seamlessly communicating with each other, working in sync. That's the idea behind a multi-controller approach.
Okay, so are you saying HybridFlow is bringing this professional kitchen model to LLM training?
In a way, yes. It combined the best of both worlds, the single controller and a multi-controller approaches, to create a hybrid system that's both efficient and incredibly adaptable. It's like having a head chef overseeing the entire kitchen while specialized chefs manage each station.
Okay, that's starting to make sense. So how does this hybrid approach actually work in practice? And what are the advantages? I mean, this is where it gets really interesting, right?
Absolutely, and that's what we'll dig into next. So with HybridFlow, think of it like this. You have a single controller at the top level managing the whole training process. That's like your head chef making sure the whole kitchen runs smoothly.
Right, keeping everything coordinated and on track.
Exactly. But then at the level of individual models, the actor, critic, and reward model, that's where HybridFlow shifts to multi-controllers. It's like having specialized chefs for each station, like the grill, the pastry section, makes everything much more efficient.
So each model gets its own little team of chefs to handle all those complex calculations.
Precisely. And this hybrid structure gives HybridFlow a bunch of advantages. For one, it's super flexible. Researchers can implement a much wider range of RLHS algorithms, which means they can really fine-tune the training process for specific needs.
So it's like a kitchen that can handle any kind of cuisine or cooking style. Adaptable.
Exactly. And on top of that, HybridFlow optimizes how computational resources are used, which makes the entire system much more efficient. It's like a kitchen designed for maximum speed and minimal wasted effort. No one's running around like crazy bumping into each other.
Okay, I'm following you. But LLMs are notoriously complex beasts. How does HybridFlow manage that implicate flow of data between all these different models, especially if they're running on separate devices? I mean, that's got to be a challenge, right? It's like having ingredients flying back and forth between different kitchen stations, potentially getting lost or mixed up in the process.
Yeah, that's a great point. And that's where HybridFlow's use of APIs comes in, these clever little communication channels that ensure everything flows smoothly between different parts of the system.
So like those runners who swiftly carry dishes between the kitchen and the dining area in a fancy restaurant, making sure everything gets where it needs to be when it needs to be there.
Perfect analogy. HybridFlow actually uses two main types of APIs. First, there are intranode APIs, which handle communication within a single model. So they coordinate all those distributed computations happening across multiple devices. It's like having a tight-knit team of sous chefs within each station, making sure all the ingredients and tasks are perfectly synchronized.
Got it. And what about communication between different models? Like when the actor needs feedback from the reward model.
That's where internode APIs step in. They manage data transfer and synchronization between the different models, making sure everything communicates seamlessly, even if those models are running on completely different machines.
Ah, so they're like the messengers carrying important messages between different departments in a large company.
Exactly. And these APIs don't just blindly send data back and forth. They've got built-in protocols for efficient data transfer, minimizing any lag or confusion. It's like having standardized containers and procedures for moving ingredients between stations, prevents spills, mix-ups, keeps everything running smoothly.
Okay, I'm starting to see how all these pieces fit together to create this well-oiled machine. But now let's talk about that mind-bogglingly efficient 3D hybrid engine you mentioned earlier. How does that fit into this culinary masterpiece of an AI system?
Ah, the 3D hybrid engine. Think of it as the heart of the system. It specifically tackles one of the biggest challenges in RLHF, efficiently switching between the training and generation phases of the actor model.
Because those two phases require different computational setups, right? Like rearranging the entire kitchen depending on whether you're prepping for a big banquet or serving a simple a la carte menu.
Exactly. Traditional systems often just duplicate the actor model, having one copy for training and another for generation. Super inefficient, like having two separate kitchens just to avoid moving a few things around.
Talk about wasted space and resources.
Right. That's where the 3D hybrid engine comes in with its zero redundancy model resharding. It manages that transition between training and generation without needing any duplicated data. It's like a kitchen that magically reconfigures itself for different tasks without adding any extra equipment.
Okay, now you've really got me hooked. How does it pull off this zero redundancy magic trick?
Well, remember all these billions of parameters LLMs have. Those are essentially stored in memory, spread out across various computing units. And when you're switching between training and generation, these parameters need to be rearranged to fit the specific needs of each phase.
So it's like moving ingredients around in the kitchen, putting spices closer to the stove when you're cooking and closer to the plating area when you're assembling the final dish.
Exactly. And the 3D hybrid engine does this with incredible precision and efficiency. It carefully aligns the parallel groups used in both training and generation, ensuring the memory allocated for these parameters can be reused without needing any duplication. It's like a system that knows exactly which ingredients need to go where and can rearrange them at lightning speed.
No wasted ingredients, no duplicated efforts, just pure computational elegance.
And that elegant design leads to some pretty amazing speed improvements. The paper reported a 20x speed up in certain scenarios. It's like going from making a meal in hours to having it ready in minutes.
Wow, that's not just faster, it's a whole new level of efficiency. But those are just numbers. What does this mean for the real world? What kind of impact could this have on everyday applications like chatbots, writing tools, even things like scientific research? Okay, so we've spent the last two parts digging into the inner workings of HybridFlow, this new framework that's really shaking things up in the world of LLMs. But let's get down to it. Does it actually deliver?
Well, the researchers put it through its paces, comparing it to other state-of-the-art RLHF systems out there. And the results are, to put it mildly, pretty impressive.
Impressive how? Give me the numbers.
We're talking speed improvements from 1.5 times faster all the way to, get this, over 20 times faster in some cases.
20 times.
Oh, hey, our listener wants to join in. What's up?
Hey there, can we wrap up and give the conclusion?
Okay, yeah, absolutely. It sounds like you're ready for the grand finale.
No problem at all. We can definitely bring it home for you. It's been a lot of details.
So we've seen how HybridFlow tackles the challenges of RLHF with this cool hybrid approach. And we've talked about those speed gains.
Absolutely. This framework is fast, efficient, and super adaptable.
Yeah, and it's not just about speed. HybridFlow is also streamlining that transition between training and generation phases.
Right. And the auto mapping algorithm is key in this. It finds the optimal model configuration to maximize performance.
Like a self-adjusting kitchen, changing to suit different styles.
Exactly. So it's not limited to specific hardware.
So what does all this mean for the future?
Well, faster training means more sophisticated models capable of tackling complex tasks.
Imagine personalized AI support that anticipates your needs.
It's exciting, and with all this power comes great responsibility.
We need to think about the ethics and ensure these systems benefit humanity.
It's about responsibility.